Guys, I am Hemachandran from Physical Education Department in Madras Christian College. In this video, we have to see about the structure of synovial joint and types of synovial joint. Come, let's go watch the video.
Ankle, elbow, knee, shoulder, wrist, all are freely movable joint, are also known as synovial joint. Another name is diarthrosis. We know that two bone surfaces move on each other. There is always a wear and tear because of friction. At freely movable joint, there is a lot of free movement between bones. These joints have special structure which prevent bone from gapping, wearing off. At the joint, bones are covered with the articular cartilage tissue. This tissue are very slippery and they reduce the friction between the bone. In some bones, such as vertebral column, articular tissues are present and observe the shocks. Bones at synovial joint are joined together with ligament tissues. In this joint cavity is also known as synovial cavity and it's filled with synovial fluid which further decrease of the friction between bones. You can compare the synovial fluid to an engine oil. It also reduces the friction in the engine vehicles. These are the synovial fluid. Synovial cavity is surrounded by joint capsule. In inner layer of the joint capsule is called synovial membrane and the outer layer is called articular capsule. Articular capsule are hold bones in place and provide stability to the joints. You must observe people complaining about joint pain of joint inflammation. This inflammation is generally caused by the friction between bones and amount of synovial fluid decreases. This condition is also known as arthritis. Arthritis also caused due to the position of uric acid crystals in the joint which result in friction between bones. You can relate the formation of crystals as throwing a sand in engine. These sand particles increase friction and the engine parts get heat up and start wearing off. Similarly, crystal form in synovial cavity causes friction. As bones move, it feels pain, inflammation and wearing off. Synovial joints are six types. They are hinge, pivot, ball and socket, candyloid or ellipsoid, straddle, and plane. First one, hinge joint. The hinge joint is very simple joint. It allows movement only one axis. It can move this way or this way. The head of the wrapper around cylindrical head of the other allowed a very stable rotation this way. In the terminology names, the hinge joint allowed flexion and extension. That it like a hinge in door allowed to only open and close. The best example in our elbow joint. They can only move only one direction, flexion and extension. Pivot joint. The pivot joint it allowed the rotation on only one axis. It rotate along long axis. A cylindrical fit into a ring of bone and ligament like radius and ulnar joint. The cap of the radius bone it nicely into this notch on the unownable ligament complete the limbs holding the bone plate and allow the radius only to rotate inside of that. The result on the forearm movement pronation and supination. During pronation, the radius base of the rotate over and around of the ulna stays still its position. Remember, the hinge joint in elbow prevent ulna from twisting. So all over the twisting happens at the radius. In this still end radius and ulna also a pivot joint. The combination of the pivot at the top and at the bottom to creating a twisting movement. Ball and socket joint. The ball and socket joint is the champion of the all joint. In structure like a ball inside of the socket. This simple and effective structure allowed to move all axes like flexion, extension, abduction, adduction, rotation, and circumduction. The ball and socket joint located in our body, hip and shoulder. In hip, as a this socket which give a biliary but limits range of motion. In shoulder joint as a shallower socket which it gives greater range of motion but takes may some stability. May that why the shoulder dislocation is common. Ellipsoid or candyloid joint. In this joint is very similar to the ball and socket joint. However, the ligament and its oval shape to the rotation, but it still has ability to rotate on two axes, which allows flexion, extension, abduction, adduction, and circumduction. Circumduction is a combination of all the others in a circular motion. The ball or oval head also slides inside the socket when it rotates along in a wider plane. You can see a pop out from the socket, so it slides back into the socket. The greater example for the ellipsoid is the wrist, also known as radius carpal joint. The group of carpal bones are rotated inside of the socket of the radius. Saddle joint. The saddle joint is similar to the ellipsoid, but the rotation is elimination mostly because of the bone structure. The structure of the saddle is very interesting. Both bones have a concave and convex structure. Concave means the surface is in like a cave. Convex means the surface is out like a hill. The concave plane a one fit on the convex plane of other. It like a cowboy on a horse. The saddle make the bottom piece and the cowboy leg make the top piece. The leg of the top piece which wrap around the body of the bottom piece allowed to move this way. The body of the top piece can glide inside of the leg on the bottom piece, so this unique structure allowed the joint flexion, extension, abduction, adduction, and circumduction and very slightly rotate. An example of the saddle on the body is the carpal and metacarpal joint of the found. Finally, the plane joint. Now really is interesting than others, but this also allow anyway. It basically two flat bone surface on one the top of the other. This surface can glide or rotate. They can usually come into the carpal of the hand and tarsal of the foot. Ligament can hold the bones together, but might allow some rotation and gliding. Another plane joint is the acromioclavicular joint, that one between clavicle and acromio process in the scapula. When we elevate the shoulder, the angle in here will just scapular ventricles. Stay healthy and thanks for watching the video.